I'm gonna go through the inverse of matrix, and I have some definition I want us to go through here. So if A is a square matrix, so first thing is that before you can find the inverse, A should be a square matrix. And if B can be found, so you got to find some matrix B such that if you multiply AB, or if you multiply A and B, and then you do the other multiplication, BA, both of them should give you the identity matrix I, depending on the dimension you are dealing with. Okay, then A is said to be invertible, and then the other word for invertibility is non-singular matrices. Okay, non-singular matrix. And B is called the inverse of A, and the inverse of A is written mostly as A to the negative 1. Right, so what this whole thing means is that if I have a matrix, so an example of that is this A, which is a 2 by 2 matrix, 2, negative 5, negative 1, 3. And then if I can find another matrix B, say that when I multiply AB, so AB, I'm going to look for AB, which is going to be 2, negative 5, negative 1, 3, and then multiplying B. And our video on multiplication of matrices says that they should have this is a 2 by 2 matrix, and this is a 2 by 2 matrix. So before I can multiply them, the columns in the first matrix and the row in the second matrix should be the same. Okay, and so what I'm going to do, I'm going to multiply the whole first row by the first column here. And so 2 times 3 is 6, then plus negative 5 times 1, which is 1, because 6 plus negative 1, negative 5 will give you 1. And then the other one is 2 times 5, which is 10, plus negative 5 times 2, which is 0, right? Because you have 10 plus negative 10, that is 0. And then negative 3 times 3, negative 1 times 3, which is negative 3, plus 3 times 1, which is 0. And then negative 1 times 5 is negative 5, plus 3 times 2, and that is negative 5 plus 6, that will give me 1. And so, yeah, AB has given me the identity matrix, right? So the identity matrix for 2 by 2 matrix. Let me look for BA and C. BA is 3, 5, 1, 2, and then A is 2, negative 5, negative 1, 3. Now if I multiply these two, 3 times 2 is 6, plus negative 5, which will give me 1. 3 times negative 5 is what? Negative 15, plus 5 times 3, which is 15. So I'm going to get 0. And 1 times 2 is 2, plus 2 times negative 1, so that'll give me 0. 1 times negative 5 is negative 5, plus 2 times 3, which is 6, so I have 1 here. So this also gave me the identity matrix I2. So it means that B is the inverse of A. So that is what we meant. If you can find a matrix B such that A times B equals B times A, and both of them should give you the identity matrix, then that matrix is invertible, and then A inverse is actually what you found. Okay, I mean, there will be other lessons on how to get the inverse, but this is an intro session to that. Now you should know that this A given here is not invertible, or it's a singular matrix. So just have it in mind that invertible matrices are called non-singular matrices, and then non-invertible matrices are called singular matrices. So it's kind of some way, so try to just go with that. Now with this, why do I think this is not invertible, right? I have A and it's given by that, so I have it there. What I'm going to do, I'm going to use some claim here. If A is invertible, then maybe I should get some matrix A such that either AB and then BA should give me the identity matrix of 3 by 3, because A is a 3 by 3 matrix, so I should get 1 0 0 0 1 0 0 0 1. This is the identity matrix for a 3 by 3 matrix, right? So if A is invertible, then these things should work. So assuming that I am claiming that maybe A is invertible, so there exists some B which is given by this B12, B13, B21, B22, B23, and then B31, B32, B33. What I'm gonna do is that I'm gonna look for the matrix BA instead. Okay. If you look at this identity matrix, the last column here, right, has 0, 0, 1, right? So I'm gonna look at the last columns of matrix BA. Okay, and that is gonna be the 1, 3 entry, 2, 3. So if I have matrix BA, I mean, I know I'm going to get something here, and then I'm going to get BA 1, 3 here. I mean, the 1, 3 entry. I'm going to get something here, and I'm going to get BA 2, 3, something here. I don't want to find them. Okay. The reason is I know that whatever values I get here for this B to be the inverse of A, then BA should give me here, this should be 0, this should be 0, and this should be 1 based on what I have here, right? It should correspond to the same column elements or column entries. Now, if you remember, in matrix multiplication, B13 can be given by summation as k starting from 1 to 3, B1k, and then AK3. And so what it means is that B1k, so I'm going to start from k is equal to 1. When k is equal to 1, I'm going to get B11 A13 plus B k is equal to 2. I'm going to get 2, no, maybe 1 2, and then A23 plus B13 A33. But if you notice this, A13 is this one, A23 is this one, A33 is this one, so all these summation will be 0. Likewise, if you do same for B23, it's the same as summation at k start from 1 to 3, B2k AK3, and that if you expand, you're gonna get B21 A13 plus B22 A23 plus B23 A33, and again A13 A23 A33, all of them are 0, so you're gonna get 0. If you do save for the last, this guy A33 BA33, that's also going to give you 0 based on this whole approach again. So it means if I multiply these two matrices, BA is going to give me some square matrix with some entries here, I don't know, but 0, and then 0 here, and 0 here. These guys, I don't know them, but I know that the last column is going to give you 0, which is not equal to the last column of this identity matrix, right? So these two guys are not the same. So it means that BA is actually not equal to the identity matrix of a 3 by 3 matrix. Like I said, the last column will be different from the last column of the identity matrix of a 3 by 3 matrix, which is not what we want. We want to get exactly the same thing. So it means that this A is not invertible, or it's a singular matrix. Okay. So this is just, by the way, an intro session to inverse of matrices. I'm going to take some theorems on inverses of matrices and write the proofs to that, and then all these are just some basis for you to understand matrix algebra. And then when we get to the main point of calculation, or maybe calculating certain things, we dive more into it. Okay, so stay tuned and follow my lesson.